The Arctic opened a route, then trapped this ship. In June 2024, the research vessel Norseman II became pinned in sea ice about 35 miles north of Wales, Alaska. It stayed there for 14 days. The hull remained intact, but its rudder was damaged, and 39,000 gallons of diesel sat inside a moving field of ice. No fuel was released. 2 years later, researchers reached a more unsettling conclusion. The trap was not a random surprise. The winds, satellites, and ice forecasts had already described the conditions that built it. Norseman II was carrying a crew and 14 scientists on a mission to study Pacific walrus abundance. This was not an icebreaker forcing a path north. It was a working research ship operating in a region that now offers far more open water than it once did. Since 1979, the open water season in the Chukchi Sea has lengthened by roughly 80 days. That sounds like safer access, but open water does not erase ice. It can leave thick pieces detached, mobile, and controlled by wind. Would you trust a route marked open if the remaining ice could move into it overnight? In early June, unusually thick and extensive ice still sat to the north. Then, strong northerly winds pushed that ice south toward the Bering Strait. The floes did not need to freeze around the ship. They only had to drift together faster than the vessel could escape. A federal aircraft searched for a channel out and found no route with less than 50% ice cover. The ship was boxed in. Responders monitored the weather, currents, and changing concentration while the people aboard waited. The danger was not spectacular. It was pressure, damaged steering, limited mobility, and fuel inside an environment where a spill would be difficult to contain. The new study reconstructed that sequence with atmospheric forecasts, satellite observations, and a sea ice model. Its conclusion was careful but important. The hazardous movement was forecastable. That does not mean anyone could predict the exact position of every flow. It means the large-scale wind and ice pattern gave operational warning that thick northern ice could be driven into the route. Then, the system reversed. Southerly winds pushed the ice back north, concentration dropped, and a path reopened. Norseman II finally moved out under its own power. 14 days ended without a spill, an evacuation, or a dramatic rescue. But not without a lesson. For a captain or a coastal community, the useful forecast is not simply how much ice covers the Arctic. It is where the thickest pieces are today, how the next wind will move them, and whether a route has room to recover when they converge. The study argues that combining weather forecasts, satellite observations, and ice models can turn that movement into actionable guidance. The Norseman II case also shows why timing matters. A route that looks navigable in one satellite frame may be closing while the ship is still hours away. In a mobile ice season, yesterday's map can describe a danger that has already moved. The Arctic is becoming easier to enter and harder to read. Shipping, tourism, research, and local travel are expanding into water where the remaining ice can move quickly and concentrate without warning from the horizon. A map showing less ice can be true while a local route becomes more dangerous. The practical answer is not a slogan about open or closed seas. It is better translation between forecasts and the people making decisions. Where the thick ice is, which wind to move it, and how rapidly a safe corridor can disappear. The Norseman II did not reveal that the Arctic is closing. It revealed that access is not safety. The next trap may begin not with more ice, but with ice that moves.